All right, so this is lesson 6.4, number 26B, on page 318. A mandatory competency test for high school sophomores has a normal distribution, so we've got the bell-shaped curve, and it says a mean of 400, standard deviation of 100. And we're going to do part B. The bottom 1.5% of students must go to summer school. So the bottom 1.5%, where would they be in the distribution? Left side, yep. For the bottom students, they're going to have the lowest scores. They're going to be down here. So bottom 1.5%. That's a decimal. You move your decimal 2 to the left. This area is going to be 0.015. 0.015 represents 1.5%. So once I find that, that allows me to find this area, because I know the area to the left of the mean is 0.5. So if I do 0.5 minus 0.015, I'll have this area right here. So that comes out to 0.4850. Any questions about that? All right, let's read the rest of the problem. The bottom 1.5% of students must go to summer school. What is the minimum score you would need to stay out of this group? So they're asking for a score. They're asking for a real-life data value. That's your x. X represents the real-life data value, that score. So that's the score that you have to find. And if you score below that, you're going to be in the bottom 1.5%. If you score above it, you're not in the bottom 1.5%. So we're trying to find that x coordinate. So if we're trying to find x, the best formula to use is right here. X equals your z-score times your standard deviation plus your mean. So we already know my mean of 400. I know my standard deviation is 100. Those are both given in the problem. If I could just find my z-score, then I'd be able to calculate x. So to find your z-score, look at your z-chart. Look for 0.4850. The z-chart always gives you the area just to the right of the mean. But I know if this area to the left of the mean is 0.4850, this area on the right would also be 0.4850, because the normal distribution is symmetric. So I'm looking out in my z-chart for 0.4850, and then once I find that, I'm going to look to the left and up, and that'll tell me my z-score. So I'm out looking out here for my 0.4850. I see 0.4850. Actually, it comes out at a z-score of 2.17. The rest of you agree with that or not? Mm-hmm. Right? Okay. So 2.17 is the z-score. In other words, if I'm more than 2.17 standard deviations below the mean, I'll have to go to summer school, I think it says, right? Make sure that's right. Yes. If I'm more than 2.17 standard deviations below the mean, I'll be in this group down here, I'll have to go to summer school. Now, I purposely just made a mistake, so I want you to see if you catch it. This is probably the place where students make the mistake the most. What do I have that's not correct up there so far?
Negative.
What needs to be negative? The z-score. Yep, the z-score has to be negative because I'm left of the mean, I'm below the mean. So even though the chart gives you 2.17 positive, make sure when you're left of the mean on your picture that you use a z-score of negative 2.17. That's probably the key thing to remember. Now I use this formula, so x equals my z-score of negative 2.17 times my standard deviation of 100 plus my mean of 400. So that's going to be, if I multiply these two numbers, I'm going to get negative 217 plus 400. X will come out to 183. So if you score below 183, you're going to have to go to summer school. If you score above 183, you won't have to go to summer school. Any questions on that problem?